Peter got his bachelor degree in 1984, his master's in 85, and PhD in 1990 at UNICAMP. At that time, he did a sandwich at Universidad Autónoma de Madrid in 88 and 89. He had a postdoctorate at Max Planck in Stuttgart, 1990 and 1992. And since 1992, he was hired at UNICAMP. He's currently a full professor there. And between 2009 and 2017, he was director of the Faculdade de Ciências Aplicadas in the Limeira campus of UNICAMP. And between 2017 and 2021, he was the communication secretary at UNICAMP. And today, the title of his talk is very anticipated by myself and I believe others, Long Journey into the Sciences and the Entanglement with Humanities. It's a very interesting abstract that I am sure you all enjoyed, and I am sure you're going to enjoy his talk. And so again, it's a pleasure to have you here, and the microphone is yours.
Okay, thank you, George, for your kind invitation. And well, you are sure that people will enjoy my talk, but I hope they will enjoy my talk. At least I see many friends here I haven't seen for a long time in the list here. Let me share my presentation. Okay. So can you see it?
Yes, yes.
Fine. So, as George said, I am now almost for 10 years at the School of Applied Sciences. It's a new campus from the University of Campinas. And going to this campus, I also switched my research interest, and so this title of the talk is kind of autobiographical summary, a long journey into the science and now my entanglement with humanities. But the motivation of what I try to develop here, what I am trying to tell you, that I will try to tell you, is kind of 25 years old now. And it's a commentary by a physicist, John Ziman, the author of, for decades, my favorite condensed matter textbook. And the title of the commentary is Science Losing Its Objectivity. But I will share with you the first paragraph that is the guide of the present talk. And I will read it. The scientist, he means here natural, hard science scientists. Know philosophy and sociology as fish know water. They understand instinctively how to live in it without being aware that they are doing so. That is, until the fishbowl is stirred or, horror of all, overturned. We seem to be living in just such a time. Science is being shaken up and forced to abandon many of its cherished customs. We need to think hard about what is happening and what we should do, not merely to survive as professionals, but to serve and delight humanity. So it was written 25 years ago, but we are still worried about this shaking up of our fishbowl. And the headline of the commentary is that philosophy of science is not independent of the way research is organized. So the research organization is somehow embedded in the philosophy of science. And the question he asks is, can scientists produce objective knowledge in a world where the research is increasingly directed towards making money or meeting social needs? And I will, for the recent years, add or reacting to political pressures that we all feel here especially in Brazil. But it's a long journey, like I anticipated in the title, and science has a consistent and successful history. But where are the caveats? There are, in this second phrase here, nevertheless, this consistent and successful history is built on some false dilemmas. And these false dilemmas are related to science communication. When I say here science communication, it's not popularization of science, it's another topic, but the communication, the essence of science, that is the communication among peers. But there is an opposition to the general public. And we have also a false dilemma that is historically constructed between basic and applied sciences. And there is another one, the most fundamental false dilemma that appears in science at schools. I mean, pre-university schools. So our fishbowl in 1996, when John Ziman wrote this commentary, are stirred, overturned, and I would add turbid. The water we are looking at when as fishes in our science fishbowl are turbid. So let me begin with the science communication. And here we have an illustration from the time, end of the 17th century, of a London's coffee shop. And the coffee shops in England at the time were very popular places for discussion and open to all audiences, among them the brotherhood of scholars and amateurs. And it's the presential part of the so-called Republic of Letters. Presential because members of the scholars of the brotherhood of scholars that shares interest in natural philosophy, that were at London at the time, or in the coffee shops in Cambridge or Oxford, they discussed their ideas there, and these were really interesting places because, for instance, in such a place, Christopher Wren, Robert Hooke, and Edmund Halley held the preliminary chats about elliptic orbits and the inverse distance square law of gravitation. Among other important ideas were discussed in such coffee shops. So when the pandemic ends, please, we all need to return to coffee shops to discuss scientific ideas. But the Republic of Letters, expressed in this network, let me explain it, was obviously a non-geographic republic. The terrain of this republic was composed by the letters exchanged by scholars, but also amateurs, aficionated to natural philosophy at the time. And what we see here is the network of citations of different members of this Republic of Letters in the letters exchanged among them. And then we see here bigger found this Christopher Wren, that was a very important member, a natural philosopher and member of this Republic of Letters. These are also Robert Hooke. You can see in smaller fonts, Pascal, Fermat, Huygens, and other names, including citations to Copernicus, Galileo Galilei, but all Ptolemeus, but also to philosophers, moral philosophers like Thomas Hobbes. Well, this guy here, I don't know if you see there is a name, Henry Oldenburg, was a member of the recently created, at the time, Royal Society. It was in 1660. And Oldenburg was an important editor of the philosophical transaction of the Royal Society. This was an idea that at that time, mid of the 17th century, what we know nowadays as science evolved from this republic of letters to associations where science, the emerging science, was institutionalized, organized. And they had the idea, after a few years, to, well, why we don't share the letters we write among ourselves, among the peers of the time, with a broader audience? And then was the appearance of the first scientific journal, so to speak, the transactions, the philosophical transactions of the Royal Society. And at the left and at the right is the introduction of the first issue, exactly saying that whereas there is nothing more necessary for promoting the improvement of philosophical matters than the communication to such, as apply their studies and endeavors the way, etc., etc., etc. That is more or less in the very beginning the identification of an important component of science, that it's communication. But what was a scientific paper at the time? Here in the middle, I have the beginnings of two of these published letters in the transaction. The first one was a diagram of lens and some luminous rays. Is a letter from Mr. Isaac Newton, that was a mathematics professor at the University of Cambridge, containing his new theory about light and colors. No, it's a part of his optics that we can identify because of the name of the author and because of the diagram as okay, that's a scientific paper, apparently. But then there were a lot of other kinds of reports, like the beginning of one that was quite amazing. It's an account of the experiment of transfusion practiced upon a man in London, a volunteer, a human volunteer. That was 1667. And the transfusion was actually a hydrodynamic experiment. They were trying to put into the veins blood of a goat, and they were studying the coagulation of blood and the flux and trying to calculate how many ounces of goat blood were into the circulation of this man, that according to this account, he survived, felt quite well afterwards, and was willing to repeat the experiment. Oh, it's that we cannot identify as a scientific report nowadays, from because of various issues, from methodological to ethical ones. But it was really at the beginning what we now understand as a scientific work, a scientific communication, very different from what we are used nowadays. And that was a long and lasting building up of a scientific narrative. And this is described in a very nice way by this guy, Dwight Atkinson, that he is a linguist, that he analyzed the philosophical transactions of the Royal Society over 3 centuries. And he made a historical discourse analysis. So, how did the scientific paper evolves in these 3 centuries? Evolved in this trend, and it continues to evolve actually. And I grasp here three findings of this in this work. That research writing in the 17th and 18th centuries was substantially influenced by communicative norms of author-centered genteel conduct. It was really close to letters, to personal letters, very personal, not this impersonal way of writing of scientific papers nowadays, independently of the discipline. It was also, there was the greater attention to scientific methodology and precision in the interest of scientific specialization brought about pronounced textual changes, but in the 19th century. Although gentlemanly norms were still in evidence. And C, by the late 20th century, expanded theoretical discussion appeared to have replaced experiments and methods as the rhetorical central piece of a research article. So we had at the beginning letters describing something, like for instance this blood transfusion. The specialization of the natural philosophy in different branches and demarcation of these different branches brought a great attention to different methodologies and precisions in experiments and observations. And these changes appeared gradually. And in the 20th century, somehow, in hard science, methodological issues were shared by all the community and discussed maybe in the professional socialization of young scientists during, for instance, their PhD. The centrality of the papers were now replaced by discussion of new theories, and instead of detailing experiments and methods. An inventory of these papers by another author shows us that experimental reports represented only a minority of articles as late as 1800. In most earlier years, like those 2 examples I showed in the former slide, previous slides, were typically between only 5 or 20% of the total, what was published in the philosophical transaction. And these reports evolved from this simple recounting of events involving minimal human intervention into polemics using experiments to question alternative reports of such events. Well, discussions among scholars at the time in form of published letters were very common. C, experimental methods and results were reported in progressively more detail over a 135 years period, as experiment came to assume a greater role in scientific argumentation. So when we learn something about scientific methods in the first in physics 101, there is this table now, the observation hypothesis, testing hypothesis, modification of the theory because the experiment doesn't fit exactly, or the theory doesn't fit the experimental result. It's not. It was not stated by Francis Bacon and immediately applied. It was really over a century maturation period. But what happened then was this evolving of the scientific paper and also the number of scientific papers in a new fashion, approaching what we now consider a scientific paper. This growing, fantastic growing of scientific outputs in that form. So another problem appeared: how to reach these different contributions and how to legitimize them, because scientific discoveries were announced in different written forms, in general newspapers, magazines, and in specialized journals, and there were many and produced in many places. So it's not so simple like in the Renaissance that everything what was important was somehow written or came to us by books. It was spread out in thousands of different short text, the so-called papers. And then the very Royal Society in the middle of the 19th century said, "Oh, we have to look to construct a catalog of scientific papers." And at the left, you can see the first page of the first volume of this first compilation of published papers. And at the right, there is a page of this catalog, and you see there, you cannot read it, but you can see it's the page dedicated to Berzelius, the famous chemist, and how those papers were put in the catalog: the name of the author, the name of the paper, and the where it was published, page, year, etc., etc., or exactly the bibliographic addressing we still use of 150 years, more than 150 years for now. So what you are seeing here is the birth of what we call nowadays the web of science, but in another format.
Peter, Peter, your sound is off. Okay.
Okay, it's off. Are you?
No, it's back. It's back.
It's back. Oh. So, what could be put into the catalog? Because there are so many different contributions. And at the time, there was also a discussion and decision of what counts as a scientific paper and what counts as a scientific journal. So there was an exclusion of very different science communications present at the time, at the end of the 18th century, beginning of the 19th century. So what, I don't know if my sound was cut, but what you were saying here, we'll repeat, is the birth of what we call nowadays as web of science. That with all somehow arbitrary criteria of what is a scientific paper and what is a scientific journal. So that was very important to map what was going on with the growing scientific output. And hence, science becomes professional. And those are the main, in my opinion, profound changes that occurred during the 19th century. It was in the 19th century that research enters universities. Prior to that, universities were only devoted to teaching, and research was made in a private scenes or in those associations like the Royal Society. Natural philosophy, how was called this beginnings of science, evolves towards what we know, what became the disciplines: physics, biology, chemistry, geology, etc. The amount of knowledge created, developed in different fronts were then clustered in the scientific disciplines. And university, when research enters university, then university becomes the locus of science. Legit science could be done only at universities and not anymore in private locations. By private locations, I mean, for instance, the lab in the 18th century of Lord Cavendish, a very rich, wealthy man that has his lab in his castle and not at a university or an official institute. And legit scientists are trained and graduated at universities. So this model of that permits the research entering university, this is what we call nowadays a research university, is actually the German model of the Humboldtian University of Berlin, created in 1810. But those societies like the Royal Society were dominated in number by laymen, autodidacts, aficionados of science, and not necessarily by scholar. And there was then during the 19th century lesser and lesser room for those autodidacts. At the end, there was an exclusion of amateurs. Amateurs was scientific amateur until the end of the 19th century or mid of the 19th century was a cherished denomination. It becomes somehow pejorative and lower class classification, and you are an amateur of science. This, we are professionals, you are amateurs. I mean, there was an exclusion of the public in participating of science. It's actually a natural consequence of a professionalization process, not only in science, but in all other professions. But we will see this has consequences 100 years after that. So we have then science as a very connected enterprise among wannabe professionals and amateurs. And when this professionalization began by research entering universities, then a very false dilemma appeared. It's engraved in our culture that of pure and applied physics, for instance. We have the physical review letters more for pure physics, basic physics, and we have the applied physics letters for applied physics. applied in the sense somehow useful, and may be pure and basic useless science. But why we have this kind of dilemma? Why we have this opposition between pure and applied? It's not natural. It is also social construction, and a very curious social construction, because this guy at the left, the famous Immanuel Kant, a philosopher, a German philosopher, wrote his Metaphysical Foundations of Natural Science in 1786, where we made create two categories: die reine Wissenschaft und die angewandte Vernunftserkenntnis. Reine Wissenschaft is pure science, and angewandte means for Kant empirically based knowledge. So angewandte Vernunftserkenntnis is not applied science, it's old science. Pure and applied science, using what we know, they are based on empirically based knowledge. But Samuel Coleridge, a poet, that's the guy at the right, translated Kant's work to English and translated directly angewandte Vernunftserkenntnis as applied science. Applied science in the sense useful science that create devices, that promotes technology. And so it's a very nice title from a work of few years ago, that the guy applied science, a phrase in search of a meaning, because the meaning of applied science evolved, transformed over these 2 centuries. We are addressing this problem. And then in the mid of the 19th century, we have these 2 essays here. The left one from Thomas Huxley, anticipating the linear model that we shouldn't speak about applied sciences, because applied sciences is simply a development of basic science. Basic science is necessary to have applied science to have useful applications of science. It's an anticipation by almost 1 century of the linear model by Vannevar Bush of how science works. First you have basic research, then you have applied research, then you have technology development, and so on. And at the other side of the ocean, there is this nice speech, a plea for pure science. So when we oppose pure and applied science, pure and applied physics, that's an old misunderstanding for a bad translation, originated by a bad translation from a philosopher by a poet. And science finally arrived at schools. So it was a long process to institutionalize, organize science and its research, entering in the university, creating dilemmas like pure and applied sciences, but it was not taught at schools. And it began only with William Sharp in 1850, when he convinced the director of the school where his son was attending, that science should be taught at schools. And it was a twilight situation until 17 years later appeared a report called Science Teaching at Schools. And then really science started to be included in the syllabus of elementary and high schools. And the debate, should we teach at schools the pure or the applied sciences? So should we give a scientific education or a humanistic education? And so we create this diaspora between scientific and humanistic education. And that's very strong because you see here, it's a very famous textbook at the time, Elementary Treatise on Physics, Experimental and Applied, not pure, from Adolphe Ganot, translated from French. This the original was in French by this guy Atkinson. And this one I had the opportunity to look. It's from 1875. And well, I look at the index and it's almost the same content that I had when 100 years later I went to high school to study physics. It's very, very, very similar 100 years later. And at the time, I had to choose here in Brazil. I don't know how it is in other places, between a scientific high school or a humanistic high school. And as a preliminary summary, false dilemmas: science, professional versus public, pure basic versus applied sciences, and the formations already when the introduction of scientific education in the elementary and high schools, the science versus humanities. And this is not. And in the last century, in the 20th century, new elements, not necessarily dilemmas, appeared. The idea we have now, the importance of citations as a measure of impact or quality, it was not, it came actually very recently, if you consider all this time span of the development of modern science. The idea of scientific merits by citations came with Robert Merton, a sociologist of science, with this book, Social Theory and Social Structure from 1949. And a few years later, there is another ingrained problem in our cafeteria discussion, that's neuroscience and big science. It was mapped by Derek de Solla Price in a famous book with this title from 1963. Of course, that the cartoon I show here is interchange the neuroscience with the big science. Neuroscience is when you are working alone or with a few students in small groups, and big science is, for instance, the paradigmatic example is, for instance, this high energy labs, with when a paper, for instance, is lists a contribution of thousands of co-authors. Right? This is something new that was characterized in the last century. And then finally we have this establishment of two cultures. That was a famous essay by Charles Peirce Snow from 1959. He was a novelist and also a hard scientist, and he regretted the separations, okay, from this that starts in the school with, are you a scientific high school or a humanistic high school? And that this separation among humanities and sciences, hard science, was endangering, in his opinion, both cultures. The cultures that don't communicate very well. And he has famous examples, for instance, that if you are in a gathering at the university, and humanists asked for a physicist if he had read Hamlet from Shakespeare, and he said, "Not, I haven't." Then they look funny to them. But if the physicists ask them, "Do you know the second law of thermodynamics?" They don't. they don't have no clue of what is the second law of thermodynamics. But somehow this was, it's not necessary, it's irrelevant. But Snow claimed that Hamlet is the humanistic equivalent, artistic equivalent of the second law of thermodynamics in science, and more or less, I guess he is right. So, where are we with this separation of two cultures? I was wondering about, and more or less motivated by John Ziman, a physicist that made this transition, devoting more and more time in his career to studying sociology, history and sociology of science. I found a broad list that I pick up 10 names that I included in a chapter I was invited to write in this book here from a colleague of mine from Campinas, the humanities and natural sciences. And excluding here Alistair Crombie, that was a zoologist, but cornerstone works in history of science. John Byrne, John Ziman, Derek de Sola-Pleiss, Thomas Kuhn, Gerald Holton, Peter Garrison, Douglas Hofstadter, and the famous novelist Ernesto Sabato. They were all physicists. Maybe the most known here is Thomas Kuhn. And I put here, it's hard to read because I see now that's not the last version of my presentation, but okay. I should have included in this book Philip Anderson, because Philip Anderson wrote, he was not devoted to humanities, but he wrote this paper manifesto in Science in 1972, this More is Different. That is probably the most influential paper written by a physicist in humanities. It was a growing importance because of his context, because of his opposition, his defense of complexity and emergence against reductionism. As a curiosity, Thomas Kuhn and Philip Anderson had the same PhD advisor, Van Vlecht. Both were, Thomas Kuhn was also a physicist and had a PhD in physics. And I will here speak from all these names a little bit about Peter Garrison, that is this guy here. And probably what you see here is the most emblematic scientific picture of the century, I guess. This image of a black hole. And Peter Garrison is a physicist, and he is member of this many, with I guess 800 guys that worked in this project to get this image of black holes. But he is also a historian of science. He has these both professorships at Harvard, physics and history of physics. He can travel, he can transit between Michel Foucault and black holes with apparently the same expertise. So if you go to his page, web page, this description is there. Peter Garrison's work in writing and film, he is also a film director, explores the complex interaction between the three principal subcultures of physics: experimentation, instrumentation, and theory. This is a very important phrase because beyond cultures, the humanistic and the scientific, the two cultures described by Charlie Pierce Snow, you have also subcultures inside one of the disciplines of the hard science, physics in the case. So our fishbowl ecosystem, if we only include physics in this fishbowl, has many subcultures that are socially constructed, basic and applied, little and big, experimentation, instrumentation, and theory. And there are tensions between these subcultures. And what those tensions can lead to. Then about this third bowfish, I couldn't avoid to remember the phrase, they're shaken, not stirred. And I will show you two examples. First, and the entanglement with science and humanities. First is this nice picture illustrating this article in Quantum magazine, reporting on a historical, I guess it was historical, conference held in Munich in 2015, because of the cul-de-sac that string theorists were reaching. No? And I mean, the headline here is, okay, string theory, the multiverse, and other ideas of modern physics are potentially untestable. So there was this historical meeting, and the problem was, of course, not settled. Scientists and philosophers asked, should we trust them anyway? I mean, the theories or the test, what to do. Some famous string theorists, they said, okay, I guess we need philosophers to handle this problem of how to legitimate, how to test or not to test, how to validate such theories that are potentially untestable. This is a frontier where the science alone needs philosophy to go ahead. But string theory is a very small community, but there is another point, quite embracing. I mean, probably in the audience here we have during this talk, there's a problem with densitive functional theory, and I got my attention to this work at the time, in the beginning of 2018, that this group was trying to test a densional an approximation to use this density functional theory, and they were testing several functionals to see what would apply better to the problem. And all we know and all we teach in condensed matter classes, the tensional functional theory based on two theorems. So every approximation has to handle the problem, have to obey have to be consistent with those theorems. But what they found out in the last 10 or 20 years, better and better approximation gave better and better results that were inconsistent with the theorems on what they allegedly are based on. So the last line is, when this trend was reversed by unconstrained functionals sacrificing physical rigor for the flexibility of empirical fittings. This was published in Science, and there was a comment about this paper in Science that said, the commentator said, oh, but this is a question of philosophy of science and not of science. So science became what? To get better and better results, even if it's not consistent with the basic assumption it should obey in principle. So I have not made a follow-up of this question, and I saw this morning that in these few years this paper has over 600 citations, and I don't know how the debate evolved, but it shows the importance we have, the consequences of not looking at the water, not realizing the water in where we are swimming in this fishbowl, and we are not paying maybe enough attention. We have to pay better attention again to the methodology, to the precision of the rigor of experiments that was the centrality of scientific papers in the 19th century. Not to speak of integrity in research. That's another different point. I want to speak here about, the idea was not to speak about ethics, But these examples and this history, my question is, should we take care of the climate changes, or there is an else missing, changes in our fishbowl? I think we should thoroughly review our dilemmas or false dilemmas, like pure versus applied, scientific versus humanities, trying to bring better ways to get the public back to science that we take apart in over our professionalization. And maybe we should reconsider to study scientific methodology, history of science or physics, and sociology of science, philosophy of science in our undergraduate curriculum. So I end here. Thank you for your attention.
Thank you very much, Peter, for the very interesting and very many ideas that you have brought up. We are open to questions. Does anyone want to start? I have, if anyone is writing anything, I have a couple of questions here. From the initial slides in your talk, would it be correct that we characterize the way that it's science that we know nowadays organize it as being very British? From the examples that you gave, obviously there is all the maybe 2,000 of years before the Greeks and all the, but the more this exponential increase in the output of science and the interest in science too. Is there any merit to this idea that it was organized in a very British way of thinking? I am not sure if this has a precise meaning, but the examples that you gave, the coffee shops in London and the Philosophical Society, and the way that they introduced it, it seemed that they were always a step ahead of everybody else in pointing the direction. So let's say that it's not exactly that they were the only ones, but they were saying, well, let's go that way, and people kind of followed because, well, they had a system, let's say, that they proposed, like the one that they said, well, how can we organize that? And they created the Web of Science of the time. And can you recognize any of that in the way that science is done nowadays?
Yeah, well, it's a very interesting question, and I would say not exactly.
Yeah, that's what I hope it.
Because you have a long tradition, scientific tradition. If we can go back to the Middle Ages with Roger Bacon, for instance, to stay in England. But we have all this, I mean, just to mention this idea of the Middle Ages as the Dark Ages, that is also propaganda from the 18th century, the Enlightenment, to say, oh, we are better than what we had before, because the Middle Ages was a very rich period in the development of ideas. So, but of course, when we have to organize an idea of modern science, the institutionalization, the organization of science, as we know, started with the Royal Society in London, but not only. No, the French Academy of Science and the Journal du Savant that was the equivalent of the philosophical transaction, started at the same time. Actually, Journal du Savant started, the first edition was in January 1665, and philosophical transaction started in March 1665. So you have different there was for many years the only two scientific, let's say, journals, but it was in England, it was British, and it was French. And many of those societies appeared in Europe. And for instance, in this network of letters, you see the name of Huygens and others. In the Netherlands, it was also in Sweden, it was in Prussia and in Italy. But I choose to talk to the narrative I showed, I followed during the talk, because of the documentation you have.
Okay.
And the most extensive study about evolution of the scientific publication was this one of the philosophical transactions. Why? Because this is a scientific journal that was continuously published during all these centuries. So you could not make the same analysis if you take the Physical Review in the United States, or the Annalen der Physik that started in Germany in the 19th century, or the Brazilian Journal of Physics that's even more recent.
Yeah.
That's but I wouldn't claim that it's a British organization.
Okay.
And also the idea of this catalog of the Royal Society was not the only one at the time. It was the most studied, well-documented history case, I mean.
Okay. I see that Luis has a question. Luis is there.
Yeah. So very nice talk, Peter. Very thought-provoking.
Thought-provoking.
Yes, and I was, listening to his definition of the different cultures between humanities and sciences, and even the subcultures within sciences themselves. And I'm wondering here that we live in a time, especially in our country and the other countries as well, where we have, there's been this consistent attack, not only in the humanities, but also in all science, right?
Yeah.
And that's something that we're not used to. That, consistent attack from not only targeting, say, humanities or just some specific niches, but medical sciences, physical sciences, we have INPE, we have many of these other any scientific discourse that tries only to tell what's actually happening is somehow trying to be discredited. And I think this is an opportunity for a reaction, and so that we can evolve and perhaps learn from these attacks. How can we, perhaps close these differences and these cultural differences to a goal that we all share, us, the humanities or the medical sciences. And so
yeah.
I'd like to see what's your take on this.
Yeah, my opinion is, see, for instance, this case of pure and applied sciences, that was a bad translation of a concept that created this. But when what was beginning to be called as physics, chemistry, and biology enter in the research university, in this concept of the Humboldtian University of Berlin, that the idea was the concept was very interesting, and it's followed is continued to be followed, that to put in one place the institution that creates knowledge and the institution that teach the knowledge. So the university and the organizations where research was done. So put it together, right? So the differentiation, initial differentiation between pure and applied sciences was politically used so that technology could also enter the universities. For instance, we engineers, we are applied scientists, and we do useful things. Not those guys that are wondering what electromagnetic waves are are useless. Just to make a joke with something that is, well, it's a paramount example, because we could not be chatting without those electromagnetic waves. But at the time, so it has a political use, but it's ingrained. And so we three here at the screen, I see me, George, and you, Luis. We are serious, right? And we grow up in the university with these subculture tensions. The castas, the castes. Theorists are the top. Some experimentalists are good, and those that make instrumentation, sorry, they couldn't couldn't get good grades in quantum mechanics too.
And they turn the screws.
Yeah, they turn the screws, exactly. So, and then the separation between pure and applied is a problem, and humanities and hard science is another one, right? So the problem is that the creation of these visions had some use in a very different time. So if you not stop to think, to revert this, to put everything together, what happened in Brazil at the beginning with this, for instance, this Abraham Weintraub, I guess that's the name of, I guess he was minister of something, education in the case. So what was the first attack? Science, okay, humanities is useless. And the second attack was, pure basic science is useless. Let's put everything in applied science. So if we continue to insist in these false dilemmas and these ideas, we are shooting our feet, how we say in Portuguese. And if we continue to have these oppositions inside the scientific community, it's very difficult to counterattack the attacks from outside, in my opinion. And I guess the most problematic collateral damage of our very successful professionalization was this exclusion of the general public, and now we are trying to gain them again. And the tool for this, together with this professionalization, started the popularization of science, science divulgation, and so on. This translation, it's also considered something that is a simplification of science, so that like people can have a grasp of something what's going on. That's also not well. It's badly conducted, in my opinion. Now we have to. Well, it's difficult in my former field. Low-dimensional physics, but somehow we have to gain the confidence of the public again. And I guess the best movement to that is what's called citizen science. So you invite citizens to participate in research projects. For instance, the beginning of that was also very interesting. It's very curious. That's the SETI program. You lend your computer time to search for radio astronomical frequencies. But now you have also video games that people online try to solve protein folding. There was a Brazilian boy a couple of years ago that in his computer was detected an exoplanet. And you have all these projects of environmental surveillance. That's also with the participation of volunteers that are trained. They are asked to participate in seminars with the experts, and they collect data and they discuss data. And so with the public participating in a scientific project, I guess that's the challenge to get our credit back.
Yeah, that's nice. So yeah, it's interesting. Like amateur astronomers, right? So they will all defend astronomy no matter what.
Yeah, astronomy is maybe the very well recalled. It's a field where amateurs are still very important in discovery and reproducibility of observations. We cannot reproduce an observation, to confirmation of observations. You're right.
Nice. Thank you.
You're welcome.
Can I ask a question, George?
Sorry? Who is... Oh, Ricardo. Yeah, sure.
Just a
moment. Your camera is not on.
Now it is. So
you see on your...
Oh, there you are.
Okay. So hi Peter, nice to see you again.
Nice to see you.
Just a question. There is a discussion going now about the inclusion of extension activities in the curriculum of the students, of the undergraduate students. Mm-hmm. And how do you see this? Do you believe that it will be a great opportunity for us to get in contact with people outside of the university, or we are somehow forced to do this now because there's a law? Do you think it's a great opportunity, or we just somehow just do it and do not take this opportunity to really talk with people outside the university?
Also a good question, because I am discussing this in a series of seminars at the School of Applied Science all the semester long. And
just to complement, if I recall from one article of you that I read in Journal of UNICAMP, you said that this idea of activity of extension was added by the American university, not by the European university. Is this correct also?
Okay, first the second question. Actually, the outreach as a mission, university mission, came. The first one was teaching, then research, and then outreach or extension, right? And the American model of university promoted extension as let's say a leading mission, and this has an origin in this land grant universities that was this movement to spread universities over over all the United States, and with the compromise to apply directly what was taught or researched at the university directly to the farmers to develop the agriculture and so on. But there were also urban land-grant universities, and then this evolved in the so-called Wisconsin model. But you had also outreach in England before that, at the same time, I mean, and I wrote this, in which article I wrote this? Oh, about some, I guess, long time ago, to actually extension has many roots. The last one that I discovered was this coffee shops in England, because there were the scholars and so many people there interested in what's going on at universities there in Cambridge and London or Oxford and so on, that there were talks. They could pay 1 pence, or I don't know what was the currency at the time, and it was the price of a coffee. So you paid that, and there were public talks. That was a kind of extension, right? These talks were held by people from the university, speaking to people in coffee shops. That the idea of pint of science is actually very old, and but as a model of university, like von Humboldt conceptualize the German model, or Cardinal Newman conceptualized the English model of university. Whitehead conceptualized the American model, where extension has this important contribution. That just to. And the first question you asked about is put extension or outreach in the curriculum. That could be a very good opportunity. It's not per se opportunity. It depends on how it will be implemented. And I guess many of our colleagues, they will try the simple way to fill the spreadsheets we have to fulfill in our reports, and I don't know how it will be in practice and how it will evolve about in the years in the following years. For instance, such a citizen science project would be a wonderful connection between science outreach and teaching, and perfectly consistent with the goals of this curricularization of the extension. In my opinion, we have to be very creative. I am afraid that the solutions will be okay. Go in your neighborhood and ask these 10 questions to 5 to 10 people, and then make a pizza chart of 60% think that science is nice, 30% that science is not nice, and that's a problem. Or in summary, I think that this could be a very good opportunity. It's not a good opportunity per se, just because it has been created.
Okay, thanks.
And sorry, that's a challenge for a physicist. Huh?
Oh yeah.
Because physics department had always the problem to what they do as an extension. Because to speak about quantum Hall effect in vulnerable parts of the town, that's not extension.
Okay, thanks.
Peter, I have a
I do have
quite. Who is that? Edson. Yeah, I was surprised that you didn't ask yet.
I was appreciating other questions and answers. So, Peter, nice talk and very insightful, I'd say. And my question, I would think about Luis' question. I think my question is along his line, the line of his question, and so and he talked about our situation, and you mentioned how the Minister of Education addressed some of the problems he thought. I think this is not a peculiarity of Brazilian community. It seems to me that this is more broad problem, and because questioning science becomes very popular in the West, for instance, too. So it's not only here. So, and my question along these ideas is, over the 3rd century after the Royal Society, roughly, right, was created, have you found anything similar in the history, and how these were, how to say, prevented or suppressed?
Well, I guess, well, first, you are completely right. This attack to science, against science, is not only here. That's going on. We have, especially, I guess, in the U.S. during the last government, that was very strong, and and it continues, right? Because once such a movement is created, and especially what you see, this my globus at the back of my room. So flat Earth is not a big problem, but anti-vax is a huge problem. But anti-vax movement exists since vaccines exist, and there are let's say waves of it's like a pendulum, right? You have the increase of anti-science or movements that then decrease, and then it increases again. This century, last century, we had a disbelief in science after the First World War, because it was science-based, with new weapons, chemical weapons developed during the First World War. After the Second World War, there was a huge movement to promote science because of the mistrust, because of the atomic bomb, the nuclear bombs launched in Hiroshima and Nagasaki. You have a very strong opposition to science during the 60s in the United States, associated with the idea that science was, everything was determined by science, and with so many social problems, the civil rights movement, there was a very strong opposition to science. There was a very strong opposition to science in England, in United Kingdom, during the Thatcher's years, with cutting of funding, and with this discourse also from the authorities that only applied science is useful, and basic science should be forgotten. And you are right. This is it not necessarily happens everywhere at the same time, but it's not confined to Brazil. But I guess I need a comment. I'm not sure if I answered your question. If something like this story I told you, if it occurred elsewhere, I guess, and it's less studied because you have less documentation, and in the Arabic world during the Middle Ages, something very similar happened. It's amazing what was going on.
It seems to me that now with the social media, internet, and I think this, I think it's not localized anymore. So very quickly it becomes worldwide. Any stupid idea becomes very popular, and people engage on that because they have to be recognized as part of some community. And being a scientist is not easy, but for this flat Earth community, it's very easy to jump in.
Yeah, but you're right, and intense traffic of data or persons accelerate the spread of everything. For instance, in the 19th century, we had, I guess, 6 cholera pandemics, but it started in a country, in India, for instance, and 2 years later it arrived in England, and then another 5 years in the United States, and so on. And when it arrived in the United States, it was back. It was finished in India. It's because the contact was very. And what we see here with the COVID-19. In a couple of months, it was spread around all the world because of the intense communication transport we have among all the countries. And the same, I guess, happens. I guess no, I am sure it happens with information, and I guess now, not sure, that we are at the very beginning of understanding this phenomenon. A few years ago, it wasn't apparently enough to denounce that this post-truth or it's a fake news, and you can identify fake news by this characteristic. It's exactly the steps necessary to identify fake news are the steps necessary to identify a fake paper, or a predatory paper, or a bad paper. Look at the authors, look at the source, look at the references, and so on. It's the same you use in science. But we learned, at least, that this is not enough. There are psychological and sociological mechanisms to believe and to propagate fake news and misinformation and disinformation that are being studied yet. We don't know the phenomena correctly, but intuitively people use this, and social media accelerate something that was praised in the past. For instance, mass psychology was used for propaganda, for uses that were cherished by great companies to sell products, and putting. And it is interesting that science. What is the most interesting thing in science? Science is never finished. Science has never the final answer. Science has always doubts. But we sell science to the public, or we let the public buy science as a definitive answer. The press used to say, science says that butter is better than, how you say margarine in English? Oh, I guess everyone understands. And
margarine. Margarine. It's almost the same. Yeah.
And the next year, science says the opposite. It depends on the crops in the United market in the United States and so on. And I guess we for decades we were used to not give attention to this way science is propagated, and we also promote science in this way. And what these other guys use is to put doubt. Oh, science is the truth. It's not. It's an eternal approaching to some truth. But we are somehow proud of this. We don't care that people say that of science. And then some people put, oh, but there is this result, this clinical trial with chloroquine that says that chloroquine helps against COVID. So putting doubts about science is a perfect strategy to discredit science. But I know that George and myself, we took opposite directions, because George somehow started with philosophy of science, humanities, and then I was a hard numerical calculus there, and now we crossed the ways.
But I am teaching a course here on Thomas Kuhn. I'm going to ask you a question. I'm going to ask you a question about that next.
Okay. Thank you for your answer.
Yeah, because I will say I made this comment about George because what I will say here is polemic. I guess, in my opinion, Paul Feyerabend anticipated all these mechanisms. He's called by many guys, many people in the community as the anti-scientist, etc. So I guess he was only denouncing, making a statement, guys, if we continue to teach science, to promote science this way, that will be a big problem. And at least the first Feyerabend. The second one, it's a different story.
In a sense, he was maybe continuing the work of Thomas Kuhn, because the question, the comment I was going to make is that with my limited amount of knowledge about philosophy of science, the one I acquired when I started my undergrad, and my late readings in the last 5-6 years, is that Thomas Kuhn was the first one that gave importance to history of science, to try to understand the epistemology of science. He said, well, everything Popper is saying and the Vienna Circle and everything, that's not what history tells us how it was done. It was not done this way. So why are you describing a methodology that has no backing in the history of science. And he was a hardcore student of history of science. History of science is huge. You cannot know everything, but he knew enough probably to be able to construct his idea of the structure of the scientific revolution, which I would like you to make a comment about that. Maybe he was the first one who was borrowing from humanities, like the study of history, that's part of humanities, to try to understand better one of the central questions of science, that is science approaching any truth or not, and how is science doing that? How can you legitimate, make legit what we do by proving or by claiming or by arguing that we are getting closer and closer to truth. And in a sense, his idea of normal science and paradigms and a crisis and the warring groups that don't know where to move because the normal science doesn't work anymore. Then all of a sudden, one group has a new paradigm that works better, solves the crisis, and then establishes a new normal science that then enters in another cycle that will repeat itself. Is this still something that resonates in the community of epistemology and philosophy of science, or this has been supplanted? Because I am not following the scholarly discussion on that.
Well, I agree with your comment, and I guess that I am not following this discussion too, but Thomas Kuhn is kind of démodé.
Démodé, yeah, I would assume so, yeah.
But I guess that on the other hand, Thomas Kuhn is not well understood.
Mm-hmm.
I guess his idea of normal science and paradigms and scientific revolutions are very interesting and still useful, because he makes this connection between internalist and externalist in the philosophy of science. No? Internalists are those that are only concerned with the goldfishes in the fishbowl, and the externalists are, well, how they live in a water with such ingredients at that temperature, and so if it's shaken or stirred or not. And this is very important because fishes are not abstract entities that live in the vacuum. You know?
Yeah.
And I like very much some, and of course, since Thomas Kuhn had this idea of this scientific structure of the scientific revolution. He also wrote prior to that an important contribution that he afterwards denied a little bit, but I like it very much. It is the role of dogmas in science.
The role of dogmas in science. No, I don't know this one. Okay.
This is a shorter one, and because we have dogmas in science, and of course, since he had this idea and a good background in history of physics, he will apply this to great revolutions. And apparently, people are okay. He applied this to quantum mechanics. Oh, I had the idea where will I apply my new theory to the biggest one, to the biggest phenomena, the quantum theory. Or first to
the Copernican revolution,
Copernican theory, etc. But I guess we can still apply Kuhn to small normal sciences. And how the community behaves with this. For instance, this is an idea of mine. I don't know if I will have time or energy or to develop it, but in my small community of low-dimensional physics, and when I started to study it in the 80s, there were two groups. One, those that treated the problem with tight binding models. I was part of it, and the other of the effective mass theory. There was opposite theories, opposite models with their communities, two paradigms, and somehow there was a peaceful, let's say, how you say convívio?
Understanding.
A more or less peaceful understanding. And I guess Kuhn's ideas could be very useful to study how sub-communities in a field handle a more or less peaceful understanding, and how in other communities there is a strong opposition trying to become the unique paradigm.
Okay. Yeah.
And so I guess there is a ground for a lot of research where Thomas Kuhn will still
relevant. Yeah. Yeah. I would make high TC. The high TC community is one there where everybody fights everybody, and after almost 30 years fighting, nobody from the outside cares anymore, because these guys are dicks. They only fight. That's the only thing they do. So and nothing comes out. So nothing. There is no solution to the crisis. Let's say the crisis has been going on for 30 years. Well, maybe with superconductivity before BCS, it was the same. I don't know as much of the history of superconductivity before BCS, but I have the impression that was more or less the same. There is this saying from Felix Braun that used to say that the only theorem in superconductivity that you can prove is that all theories of superconductivity are wrong. So
okay. The superconductivity stuff, it's a very nice example. You can apply Thomas Kuhn directly.
I think so.
Before BCS, you have a paradigmatic time, a pre-paradigmatic time. So you have to collect. There is this phenomena. You have to collect. You have to try. Then you establish a paradigm. It's not absolute. It has flaws. High TC, for instance, was maybe the biggest challenge. And now you have a crisis.
It led to many years of very fruitful research, because you could thousands of new superconductors were developed, where people were trying to increase the electron-phonon interaction. If you make an electron-phonon interaction very strong, TC is going to go up. That's how TC went up from 9 Kelvin to 20 something. But then there is this, who was that? Bert Mattis. He used to have the saying about how do you get a good superconductor? Avoid oxygen, avoid magnetism, avoid low dimensions, and avoid theorists. And high TC has oxygen, high TC is low dimension, high TC has magnetism, and well, the theorists, I believe he was right, but the other three he was wrong.
Yeah, BTS promoted a nice normal science period.
Yeah, that's true. That's true.
And, well, ITC is maybe the black body radiation that needs another step.
It's something new, some new way of thinking. I don't know. Yeah.
And we are not used to. We are not comfortable with crisis. That's a problem, and that crisis can rest for decades.
Exactly. Yeah, I know that Thomas Kuhn is demodé. I thought so. I said, well, but I don't have. I like Feyerabend very much, but I think that Feyerabend is more difficult to encapsulate and explain to the students. So I went for Kuhn. That's much easier. And the students seem to relate with the idea. It's simple enough that you can explain. But I think it can still, as you said, can still be applied to some interesting crises or normal sciences.
Yeah, because
whatever.
In social science and humanities, you have this wannabe paradigms dispute, and while in some parts Walter Benjamin is still the main authority or framework to discuss some ideas. Thomas Kuhn in other communities, this science technology studies and strong some new developments, social science and technology studies is how the field.
Okay.
It's incomplete, and to make the criticism of great philosophers is the goal for many academics, right?
Okay, so I think we are still recording. So I don't know if Edson mentioned that to you. We record and we post the videos in our YouTube channel together with the slides. I'm gonna send you an email later asking for the slides. Okay. And then I send you the address of the YouTube channel so you can pass it along to students or to whoever you want to, so that they can take a look. Okay. And I am sure that I am gonna be the organizer for the next semester, and I'm gonna be calling you again.
Okay.
So that's so you are warned already that you're gonna receive an email asking for to come back, and it's always on Thursday at 2 p.m.
Fine, it will be a pleasure.
So thank you very much for accepting our invitation. And it was a very nice talk. I gonna watch it again.
Okay, me too.
Okay, so very good to see you again.
Okay.
And once the pandemic is over, I will try to arrange a trip to Campinas, and then we can meet in person.
And drink a beer in a coffee shop.
In a coffee shop, yeah, and continue our conversation.
Fine. Okay. Thank you very much.
Okay. Thank you. Nice seeing you. Bye.
Bye.
Bye. The 3